Okay, we have two construction contracts that are to be randomly assigned to one or more of these three firms, 1, 2, 3. And any firm may receive both contracts if each contract will yield profits of 90,000 for the firm, and we want to find the expected profits for firm number 1. Okay, now we have two contracts to be assigned, and the receivers can be one of those three or two of those three. So therefore, the first thing that I would like to construct is actually the sample space for how these two contracts can be assigned. So I would suggest you to pause the video for a moment to think about by yourself. How would you find the sample space that two contracts are to be assigned to these three firms? So again, pause the video now. And then here's the sample space. Okay, it's not too late if you still want to pause the video so that you can think about this one. Okay, so here's the sample space. Two contracts. The first contract can be assigned to firm number 1. Second one can be assigned, it's possible, also firm number 1. Similarly, I just want to list all these possibilities in a systematic way so that I don't miss anything, right? So now this means first contract firm number 1, second contract firm number 2, first contract number 1, second contract firm number 3, and so on and so forth. So now the continue 2, 1, 2, 2, and then 2, 3, and then 3, 1, 3, 2, and 3, 3. So that's all the possible assignments of these two construction contracts, right? So now, because what we are trying to find, we are trying to find the expected profits for firm number 1, okay? So therefore, I want to just focus on firm number 1. So I'll let Y be the number of contracts the firm number 1 receives. Firm number 1, not I, this is number 1, receives. In this case, Y can be 0 contract, 1 contract, or 2 contracts. Okay, so that's the probability distribution that I want to find, Y P of Y. So when it is receiving firm number 1 receiving 0 contracts, so let's see through here. I see this is the first case that no firm number 1, so let's highlight that. So this is the first case, and if you read through, this is the second case, and this is the third case, this is the fourth case. Okay, out of the total 9 possibilities, so therefore I know this is 4 out of 9. Similarly, receiving 1 contract, this will be the first one, second one, and third one, fourth one, so 4 out of 9 again, right? Receiving 2, that's the only possibility right here, so therefore it's 1 out of 9. And then we want to find the expectation of this Y, the number, actually not yet, right? Because we want to find the expectation of the profit, not the expectation of the Y. Okay, so now actually I want to define a new variable. So I'm going to define a new variable. Let's call it say X. How about I add another subscript? Let's say Y1 means the contract firm number 1 receives. So therefore this is what we are trying to do, right? So define X1 to be the profit earned by firm number one. And obviously, how much profit? Each contract yields 90,000. Therefore, contracts will be 90,000 times the number of contracts, which is the number of contracts received by by firm number one, which is Y1, right? So what we actually really want to find is expectation of these profits earned by firm number one, which is the expectation of 90,000 times Y1. And according to the rule that we have, we can actually factor out the constant, which is expectation of Y1. 90,000 times expectation of Y1. And let's do the algebra. 90,000 times expectation of Y1 is 0 times 4/9 plus 1 times 4/9 plus 2 times 1/9. Okay, let's do the algebra. This is going to be 4 plus 2 is 6/9. 6/9 is 2/3. So 2/3 times basic 60,000. Okay, 60,000. So that's the expected value, expected profit for firm number one. Now, the second question is, if firms number one and two have the same owner, what is the owner's expected total profit? So now, similarly, we can quickly define, say, Y2 be the number of contracts. Like firm number two, right, receives. And similarly, X2 be the profit earned by firm number two. And if you look at the distribution one more time, distribution is exactly the same as this one. They are kind of the same. So we already find the expectation of Y2, which actually is the same as this one, which is the same as expectation of Y1. It's going to be 2/3. And then now the expectation of the total profit for this owner is actually the profits from firm number one plus the profits for firm number two. So therefore, this is what we are trying to compute, which is expectation of X1 plus expectation of X2. And if you do the algebra, these two are the same because they are just the same type of variable. They share the same probability distribution. Each contract yields the same profit. So you just double the 60,000. Just double it, right? So it's going to be 120,000. So that gives the solution for this problem. It's a really good problem. In real life, that's how we compute expectation to make decisions.